today I'm going to explain you what binary is. So we all know that computer uses electricity to work. So inside the computer, the CPU, and inside the computer CPU, there are transistors which are using the electricity to be in one of the two states, on or off. So the on state represents number 1 and off state represents number 2. So we can see that one transistor is not enough to represent big numbers because it has only two states. So now let's leave this part for later. I'm going to come back to this part soon. And let's go to the thing that we all know very well. We know that now we use the decimal type of counting. So decimal uses base 10 numbers to represent bigger numbers. For instance, here to represent 1860 by decimals, we do it like this. We have the 10 powered by 0, which is 1. We have the 10 powered by 1, which is 10. We have the 10 powered by 2, which is 100. We have the 10 powered by 3, which is 1000. And we can continue like this infinitely many times. So here we see that 1 times 2 is 2. 10 times 6 is 60, 100 times 8 is 800, and 1000 times 1 is 1000. So adding up these numbers, we are getting 1000 plus 800 is 1800, plus 60 is 1860, and plus 2 is 1862. So now let's go back to the binary system. In decimals we use powers of 10 to represent bigger numbers. In binary system we use powers of 2 to represent bigger numbers. So in this case we have 2 powered by 0, which is 1, then 2 powered by 1, which is 2, then 2 powered by 2, which is 4, 2 powered by 3, which is 8, 2 powered by 4, which is 16, 2 powered by 5, which is 32, and 2 powered by 6, which is 64, and so on until the infinity. So now we know how to use the binary numbers, binary system, and now let's represent, for example, number 9 with binary. We write it like 1001 because 2 powered by 0 is 1, 1 times 1 is 1, then 2 times 0 is 0, then 4 times 0 is 0, then 8 times 1 is 8. So we're adding up 8, then 0, then 0, then 1, and 8 plus 1 is 9. Mm-hmm. So each of those numbers is called binary digit, and which is the same as bit, and also 8 bits equals 1 byte. So for instance, when you see that computer's CPU is 4 gigabytes, like 4 gigabytes of RAM, it means that it is 32 billion bits. So now we know how to represent numbers in binary system, but we don't know how to represent letters and words. For this we have the ASCII scale, which is basically every letter in alphabet has its own number. So to write a letter in binary system, we're doing it like this. So in this case, we're finding number n. We have here 1 times 1, which is 1, it's 0. 4 times 1 is 4, 8 times 1 is 8, 16 times 0 is 0, 32 times 0 is 0, 64 times 1 is 64, and 128 times 0 is 0. So we're adding up 64 plus 8 plus 4 plus 1, which is 77. So we're getting letter n. So now we know how to represent letters, numbers, and words. Thank you for watching. Bye.